According to Einstein, space, or rather space-time, seems to be elastic. You can imagine it as a kind of rubber-like construct. Every form of matter, whether a human being, a planet, or a black hole, causes space to be deformed, and this deformation in turn is what we call gravity. But that is a topic for another video. This property of space-time should also mean that, for example, when a planet moves through space, it must generate waves in the curvature of space, similar to how a ball moving through water produces ripples. However, these waves are not oscillations of water particles, but deformations of space itself, tiny compressions and stretches. Now, the rubber construct analogy may not be entirely accurate. Space-time is indeed elastic, but not nearly as elastic as rubber. In fact, it is extremely stiff, much stiffer than steel. Accordingly, the waves are very subtle. We humans deform space-time with every movement, but because it is so incredibly rigid, the effect is minimal. Only planets or black holes with enormous masses can deform space significantly and thereby generate more noticeable waves. Unfortunately, these waves in space cannot be directly measured because any measuring instrument itself is curved along with space and therefore would not register a change. But if one sends light through space and a gravitational wave passes along that path, the light must travel a slightly longer or shorter distance at certain points. As a result, the light takes a tiny bit longer or shorter to cover the distance, and this difference in time should be measurable. About 1.3 billion years ago, two black holes are said to have collided far away. That must have been an event of gigantic change in space-time, and the resulting gravitational waves were, in fact, measured not long ago. This was such a great achievement not only because it confirmed that Einstein's idea was correct, but also because it suddenly opened up a completely new way to observe the universe: gravitational wave astronomy. If one can measure this time difference of light at several locations on Earth, it becomes possible to calculate from where the gravitational waves originated. Up until now, there have been two ways to observe the universe, two observation windows: radiation, meaning light, the photos we take of the cosmos, small particles that reach us from space. But soon, it may become possible to observe the universe in a third way, through gravitational waves. This could significantly change our worldview. Scientists compare it to a deaf person suddenly being able to hear, because we would gain a fundamentally new source of information about countless events in the universe, even from the most distant past, about everything involving massive movements, such as such collisions or even the Big Bang. Thanks for watching.